Let's have a look at practice question set number 19 now. Start off with a good question, real good question. We've got 6 graphs here. 3 are electric field versus time, and 3 are magnetic field versus time. And we want to know in question 1, which graphs represent a situation in which EMR, electromagnetic radiation, could be produced. Well, fundamentally, forget about these graphs for a second. Fundamentally, what is it that causes EMR? Yep. Accelerating charged particles, right? Charged particles that are at rest will generate a gravitational field and an electric field, no magnetic field. Charged particles that are moving at a constant speed will generate a gravitational field, an electric field, and a magnetic field, but they're constant values. Charged particles that are accelerating will generate all of those things, but the electric field and the magnetic field will be changing. That's why it's important to have an accelerating charged particle generating EMR, because we need the changing electric and magnetic fields. So let's, with that in mind, take a look at these graphs here now and try to identify what's going to generate EMR. Is number 1 going to generate EMR? Yes. Why? Because it's got a changing electric field. Is number 2 going to generate EMR? No, constant electric field. 3? Yes, because it's a changing electric field. 4? No, because it's a constant magnetic field. 5? Because it's a changing magnetic field. And 6? Even if the shapes are odd, any changing electric field, any changing magnetic field will generate the opposite. So changing electric field generates changing magnetic field. Changing magnetic field generates changing electric field. So we're going to get EMR regardless of what the shape of it is. We're used to seeing stuff like this, but regardless of what the shape is, as long as it's changing, we're going to get EMR produced. The answer is going to be, what do we got here? 1, 3, 5, and 6. 1, 3, 5, and 6, D. 2, a stronger intense source of gamma rays would most likely indicate that what has occurred? Well, remember the 7 types: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Radio waves and microwaves are both produced by oscillating electric charge. Infrared, visible light, and ultraviolet were all produced by? No. Yeah, electrons transitioning from one level to another within atoms, from a high level to a low level. X-rays were produced by rapidly decelerating electrons, and gamma rays were produced by, nuclear decay, which really boils down to matter being converted into energy. So the answer would be D for that one. 3, the relative direction of the electric and magnetic field components of EMR is perpendicular. Now, perpendicular is the big word in this unit, right? In the last unit as well, really, right? When we're dealing with magnetic fields, magnetism, magnetic fields, magnetic forces, perpendicular is big as well, but especially in this unit. Relative to the directions of the electric and magnetic field components, the direction of motion of the energy is which way? Perpendicular. Listen, if you get a question that asks you for a direction in the context of EMR in any context, the answer is perpendicular. Like, don't say, oh, I think I'm going to be really, really smart here, and this one's going to be parallel. No, it's not. It's going to be perpendicular. Okay? If we're talking about EMR, the answer is going to be perpendicular. 4, which of the following sets of EMR is arranged in order of increasing photon frequency? Increasing photon frequency. Okay, we memorized the order of them, right, in terms of increasing frequency. We had, what was the first one? Radio waves. Infrared.
Radiation, visible light, ultraviolet, X-rays, gamma rays.
All right, so now all we got to do is read them off, right? Now all we got to do is read them off. We're certainly not going to start with gamma rays, so it's not going to be A or C. Radio waves, it's going to be B, right? Radio waves, ultraviolet, and gamma rays. We're only listing 3 there, but certainly the 3 that are listed are in that order: radio waves, ultraviolet, and gamma rays. Hey, how could we change this question in order to make A the correct answer? Matt?
In order of decreasing photon.
Good. There's a couple ways we could do that. One is in order of decreasing photon frequency. Now, if we get a question that says in order of decreasing photon frequency, I wrote down the 7 types of EMR there. We may not need to answer the question that we were asked here, But if we were asked decreasing photon frequency, we would definitely want to write it down and then just read them backwards, right? What's the other way that I could ask this question in order to make A the correct answer, Alex? Good. Increasing photon wavelength. Increasing wavelength is exactly the same as decreasing frequency and decreasing energy. Energy and frequency go together, right? They're related to each other. Directly related to each other. Okay, number 5. I think this is the last one, isn't it? High energy particle accelerators can be used to accelerate protons to close to the speed of light. Magnetic fields are used to produce circular paths that these protons follow in the accelerator. The Large Hadron Collider is designed to accelerate protons to an energy of 7 tera electron volts. So we're accelerating these protons in the Large Hadron Collider to something like 99.99% of the speed of light. So fast that these protons actually gain significant mass. They get very, very heavy as a result of that. Now, the question says, EMR, known as synchrotron radiation, is generated by these large accelerators. This radiation is created by what? Well, we haven't talked about synchrotron radiation, right? So how are we supposed to know how it's produced? How is any type of EMR produced? That's what you got to go to, right? How is any type of EMR produced? By accelerating charges. So we're looking for an answer here that is some form of accelerating charges, right? Make sense? Which one is it? Which one is it? Yeah, C. How is that accelerating charges? The protons as they move in a circular path of the accelerator. Yep. Well, yeah, it says, yeah, it says that, but, yeah, I guess, but maybe it just says, maybe that option just says, by the protons as they move in the circular path.
Yeah, but it says accelerator.
Yeah, but maybe the next time it doesn't say that. Yep. Yeah, if it's moving in a circular path, it experiences a centripetal acceleration, an acceleration directed toward the center of the circle. Maxwell didn't say that the charged particle has to be speeding up. He didn't say the charged particle has to be slowing down. He said the charged particle has to be accelerating. And when a charged particle is going in a circle, it's accelerating toward the center of the circle, right? A centripetal acceleration. So we still generate EMR there.